So yesterday what are the elements we have written? Once again tell me. Like all P, S and P block elements are done. Okay. Now today we will write D block elements also. Okay. Remaining properties we will discuss today. Like atomic radius, all these are very important. But before I start periodic properties, we will finish the elements of D block elements. Like D block elements, what are the things we have? Tell me once. D block. Yes. So tell me what are the elements we have? Starts from scandium 21. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Okay, 30. So 21 to 30. Next. Ikkada yttrium 39. Yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, rhodium, palladium, silver, cadmium. So starts from 39, ends with 48. Ends with 48. Okay, next. Here it is lanthanum 57. Okay, next lanthanum, hafnium 72. Okay, hafnium. Next tantalum, tungsten, rhenium, osmium, iridium, platinum, aurum, mercury. Mercury is number 80. Next, here actinum, that is 89. Next element starts from that is rutherfordium 104, RF. Okay, so you just remember this line. See how I am writing RDS BHM DRC. Okay, you make some, I will tell you how to remember also. See, first what I am saying, RDS. First one is rutherfordium. The next dubnium, Db. Next seaborgium, Sg. Next one is borium, that is Bh. Next hassium, Hs. Next meitnerium, Mt. Next darmstadium, Ds. Okay. Next Rg, roentgenum. Next copernatium, Cn. So its number is 112. Number is 112. So these are all D block elements we have. So first group elements, I mean 3D series. See, what is this series called? 3D series. Elements are 3D series, but belongs to which period? Fourth period, but you can say 3D series elements. 3D series, but fourth period elements. Okay, because we know D subshell starts from 4, n equals to 4. Okay, if n equals to 4, L can be 0, 1, 2, 3. Okay, next this is fifth period, sixth, this one is 7th. So all here what we have? Lanthanides. Next here, yeah, that's it. So what is the other thing is, you need to remember the elements like this also, like this, because in coordination chemistry we will deal with complexes. So the complex will be given with cobalt as well as rhodium, or with nickel, or with palladium and platinum, and we need to compare them, their spectral data, the things we need to compare. So try to remember them in some manner, like I can say some mnemonics, it's your wish to listen or you can make your own. So you can see this one, you know, trailer, you know, na? Trailer, teaser for movies. Okay, so just see this teaser, TIZHR. It's a homophones and chavatham telusa meeku, homophones and ekkada in English we'll study homophones. Manam pronunciation same untadi, spelling anta different untadi. So it is also like a homophone of teaser, like TIZHR. How you will pronounce them? Make a word out of it. అట్లనే ఉంది కదా టీజర్ అని గుర్తుపెట్టుకోండి. నెక్స్ట్ just remember it as vanadium, na? Vanadium, niobium, tantalum, dubnium. What is that? Vanadium, niobium, tantalum, dubnium. So hard to remember. but remember it like 1/3. What I am saying? 1/3. 1/3. All ఫస్ట్ లెటర్ సౌండ్ అయితే వస్తుంది కదా, ఫస్ట్ లెటర్ సౌండ్ వస్తే మనకు గుర్తు వస్తుంది ఖచ్చితంగా ఒక 2 సార్లు ప్రాక్టీస్ చేస్తే. ఎప్పుడైనా న్యూమోనిక్ అనేది ఇబ్బంది పెట్టొద్దు, మనకి కొంచెం హింట్ ఇవ్వాలి, అంతేగాని దాని మీద మనం డిపెండ్ అవ్వద్దు. సో వీ నీడ్ టు స్టడీ దెమ్ ఫస్ట్. న్యూమోనిక్స్ విల్ ఓన్లీ టు రికాల్ దెమ్ క్విక్లీ, దట్స్ ఇట్. ఓకే, నెక్స్ట్ just look at this. Chromo, how it is? Chromium, molybdenum, what is that? Niobium, molybdenum. Chromium, molybdenum, tungsten. Like chromo, how it is? Just read like a word. You can able to remember them? Yes. Next, this one like ferrous, ferrous, ruthenium, osmium, hassium, ferrous. Can you able to remember that word? Yes. Next, this one like, just read this word, matrix. See, manganese, technetium, rhenium, borium. So all the words are covering here. Yes or no? So that is also one code word you can remember. Okay, next, this is a name, you can remember it as like a, you know, Karim Nagar, you know, like that, Karim. See, Ka means cobalt, R means rhodium, I, Karim, I means iridium, M means meitnerium. Can remember them? Yeah. Next, this one as nipped. What is it? Nipped, nickel, palladium. Like Pa is pronouncing more now, like stressing, it means 2 P's are there. So one is palladium, next one is platinum, tungstenium. Okay, remember that. Next, గుర్తు పెట్టుకుంటారా, అర్థమవుతుందా, లేకపోతే మాకు తెలుసు సార్ అనుకుంటే సైలెంట్ తీసుకోండి, లైట్ తీసుకోండి. నెక్స్ట్, ఈ గ్రూప్ మనకి ఎట్లయినా తెలుస్తుంది కదా, ఏంటి? కాపర్, సిల్వర్, గోల్డ్, ఆర్జీ. ఓకే, next, this one definitely we should know. What is that? Zinc, cadmium, mercury. Next one is copernatium. Remember copernatium. What is the number of copernatium? 112. That is also important. Okay, done. So if you want, you can make a note of these elements. Done? Okay, next. Okay, so today's our task is to remember. Okay, we are left with lanthanides, actinides now. So one more day I will tell you lanthanides, actinides. All together you will forget everything. So every day one part. Next, atomic periodic properties today we will discuss. Okay, so what do we mean by periodic properties? Like there are some properties like size, volume, some chemical properties like ability to lose the electron, we can say in terms of ionization energy, and ability to gain the electron we will say in terms of electron gain enthalpy, and also electronegativity, electropositivity. These are all what? Periodic, properties of the elements. They changes in a regular fashion. In a regular fashion means like we have 18 groups like this now. So from here to here they will have a particular kind of trend. Again if I start in the bottom, again they will be following some kind of trends. So the changes in properties in a regular fashion is considered to be periodic properties. Okay, so now first property, periodic property is atomic radius. What is that? Atomic radius. So once read, do we have anything related to it? So now how can you understand the basic definition? What is the basic definition of atomic radius? If this is a nucleus, we know there will be inner shells. So these are the inner shells, and let us say this is outer shell. Now the distance from the nucleus to the outermost shell of an atom is considered to be radius. Okay. Now in the periodic table we have metals, non-metals, some metalloids like this we have. Okay. Like for metals you need to express atomic radius in terms of metallic radius. What is it? For metal atoms you should say it as metallic radius. For non-metals particularly for noble gases, you should say it as van der Waals radius. What is that radius? Van der Waals radius. Okay, and other non-metals are there now. For them, we will say in terms of covalent. So we have three types now. One is metallic, other one is covalent, other one is van der Waals. So metallic radius, easy to understand. We know metals are ridged. Ridged means very hard. Like if I put this one metal atom beside it, if I put like this, they won't overlap with one another. They just be side to side, right now. So it means like this you can understand. Like this it will be. When it comes to covalent, how it will be? Covalent bond is formed by mutual sharing, we will say, means they have some ability to get overlap, that atomic orbitals get overlaps. Like this we will get. Yes or no? Some kind of overlapping is there. So if you want, let us make it more. Yeah. So if this is the nucleus, this distance is called, let us say, D. Which type of bond it is? Covalent bond or metallic bond? So now the distance is like metallic distance I am saying between the two nucleus. Then the radius can be considered as metallic radius. So this is metallic radius. In this case, see, this is R covalent I am saying, or D covalent I am saying. D covalent. Then R covalent, what happens? D covalent by 2. Why? Because if I say something like a diameter, half of it we are considering it as radius. You can understand in that way. Next, when it comes to van der Waals radius, so van der Waals radius is considered for noble gases. For which gases? Noble gases. And also between two covalent molecules. Between what? Two covalent molecules. So between two covalent molecules and ento chuddam chudandi. See, let us consider hydrogen atom here and one more hydrogen atom is present here. They will overlap like this and they will make a covalent bond first of all. So what is this? This is H2 molecule. H2 molecule. Now one more H2 molecule you consider here. Like this. Okay. Now we know what is this distance called? D covalent. Right? Okay. So now from this point to this point, this is D covalent we are saying. Now from this point to this point, it means adjacent two molecules I am considering. This is one molecule, the other molecule. So here to here the distance whatever you are seeing, that is some x distance you can consider. What is this distance? X. Now half of that x is considered to be van der Waals radius. Okay, so van der Waals radius given between the two covalent molecules. What? It is given between the two covalent molecules or between, see, we know noble gases won't make any bonds. Right now they independently exist like this. They don't even be close to each other because we know gases will be far from each other. They will move here and there. So there will be some space in between. Yes or no? Okay. So for these noble gases, we are expressing the radius in terms of what? If this is distance is x, so radius becomes x by 2. Okay. So this is called what radius? Van der Waals radius. So now by looking at the like this general images only, you can able to say which radius is more? Which radius is more? Quantity, van der Waals. So R van der Waals greater than R metallic or covalent. See, for metallic there is for covalent there is small kind of overlapping, but for metallic they are very rigid. So it means which distance is more? Metallic. So first van der Waals, next metallic, and least is covalent. Okay, so just remember this. Okay, so when we will be using covalent radius, then covalent radius is for normal the molecules or the species which the elements which form covalent bonds, like hydrogen. See, tell me, hydrogen exists in atomic form or molecular form in the nature? Molecular form. So that molecule is formed by a covalent, I mean sharing of electron only, no? So it means its distance or the radius is expressed in terms of covalent radius. Similarly, halogens also covalent radius. So for covalent molecules, atoms in the covalent molecules you can say. Whereas this one for noble gases, van der Waal is for noble gases as well as between the covalent molecules. This is one molecule, the other molecule, like this you can consider. Okay. So now how it varies in periodic table. So consider a group elements, like first group elements, tell me what are the first group elements? Lithium, sodium, potassium, rubidium, cesium, francium. Up to here it is fine. Okay. Now write its electronic configuration. 1s2, 2s1. For these it is 3s1. For these it is 4s1, 5s1, 6s1. See, you are increasing the shell number here. Shell number is increasing or not? If this is a nucleus, first shell, second shell, third shell means, so as shell number increases, what happens to the distance? Increasing. So radius increases. So down the group atomic radius increases. So you can say down the group atomic radius increases. So what is the example? Why it is increases? Because the newly added electron, see what is the atomic number here? It is 3, it is 11, it is 9, means whatever the increase in number we are seeing, that newly added electrons enters into higher energy shells, higher levels or shells. Therefore distance from the nucleus to that shell increases, therefore size also increases. So lithium less than sodium less than potassium, rubidium, and highest is for cesium. Clear up to here everyone? Yeah. So the next, how it varies in periods of periodic table. So periods generally you take left to right. Second period elements you tell me. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. The next, neon, I am writing it separately, keep it separate. We will discuss only about this first. Okay. So now tell me its electronic configuration for lithium. 1s1, 1s2, 2s1. This one is 2s2. This one 2s2, 2p1, 2p2, 2p. So if you keep on adding this new electron, but that electron is added to the same shell number, right? But in this case shell number is getting increased. See, as atomic number is increased from 3 to 11, 11 to 19, what is happening? That newly incoming electron going to the higher energy shells. But in this case, it is 3, 4, 5, 6, 7, 8, 9. As atomic number is increasing, but the new electron is entering into the same second energy level only, right? Now second shell only. Therefore, what happens if this is the nucleus, first shell, second shell? See, what happens as atomic number increases, number of protons in the center also, nucleus number of protons also increases. If protons are increasing, positive nature more now what they will do, that new electron also entering here only. What it will do, this negatively charged electron strongly attracted by the nucleus. So if it is strongly attracting, what happens to the size? Decreases. So that's why when we are moving from left to right in the periods of periodic table, size decreases. So in periodic table left to right, size decreases. So which means, which is the smallest size here? Fluorine. Okay. Yeah. So just tell me here, beryllium larger, then that's it now. Okay. Now what about neon here? See, I told you there are three types of radius. What is it? Metallic, covalent, van der Waal. Which is more? Van der Waal. So for noble gases, I told you we will be measuring in terms of. So all the it means in any period you take, in that respective period, noble gases will be having highest size. Which one will be having highest? Noble gases. Up to first group to halogen family, you just take normal trend as per the concept. But noble gases should be placed at the first, means it should be the highest. Why? Because its radius will be expressed in terms of van der Waals. So here it should be near. So what I am writing here is, in respect to always noble gases, this like write it as a note point, always noble gases will have highest atomic radii in respect to periods. Clear up to here? Yeah. Next, let's see some questions. So you can see the experimental data also here. So this is lithium, beryllium, boron, all these are period elements, second period elements. See what is happening, lithium to fluorine, if they move 150 to becoming 64, means size increased or decreased? Decreased. This is a fall, you can see. Similarly for third period elements also decreasing. Next, in a group, if you see lithium to sodium, if you go down the group, what is happening, 152 changes to 262. So size is increasing down the group. So something like this, the graph is looking like this. Okay, even halogens also you can see down the group it is increasing. Okay, this is the trend we have as per the experimental data. Okay, next, we'll come back to this. Just see 1-2 questions and answer them. What's your answer for this? The correct decreasing order of atomic radii of second period elements. Just now we discussed. So what is this? First lithium, beryllium, boron, carbon, nitrogen, oxygen, like this we have. That's in the left to right, what happens? Decreases. So where do we have? Second option. Next, match this, try to match this. చెప్పండి. ఓకే దిస్ వీ హ్యావింగ్ డిస్కస్డ్ అంటారా ఏంటి, తెలుసు కదా. ఓకే, జస్ట్ హోల్డ్ ఆన్ ఫర్ సమ్ టైమ్ అదర్వైజ్. ఓకే, విల్ డిస్కస్ అబౌట్ ionic radius. See, for any element, if let us consider A is an element, atom. Okay, I am removing one electron from it. I am removing one electron. -1 means removing one electron so that it becomes A plus. Okay, now I am adding one electron to this, becomes A minus. So anion, atom, cation. So this is anion, this is atom, and its cation. So tell me, where do we have more positive charge? Relatively in cation. So more positive charge means nucleus forces are more now. Like if this is nucleus, these are electrons, consider. So if positive charge is more means what it will do? That positive charge strongly attract the electron cloud. ఇక్కడ electrons ఉన్నాయి కదా, వీటిని strong గా attract చేస్తుంది కదా, అప్పుడు ఏమవుతుంది, size decrease అవుతుంది. So always remember, cation will be having smaller size than its atom. And anion, what about anion? Anion has more